If you are joining us right now, I want you to take a second and think about the last time you had to read a manual.
Right, like for a piece of furniture or something.
Exactly. Yeah, you buy a new bookshelf, you open the box, and there is that flimsy paper booklet just sitting right on top.
Oh, I know the exact kind you mean. Just a tiny, confusing diagram.
Yeah, and it tells you to, like, insert tab A into slot B, and that is it. It is entirely mindless utility.
Right. It is purely functional.
It really is. I mean, the manual does not care about your hopes, your dreams, or, your deep-seated anxieties about building furniture. It just impassively points and says, well, there it is. That is a shelf.
Because it assumes a perfectly rational world,
Right.
right? Where the user just wants to achieve a specific outcome, and the instructions are just the shortest path between a pile of wood and a finished product.
Right. Tab A is either in slot B or it isn't. It is clean. It is comforting, even.
Yeah, we like things to be visible and categorized.
Absolutely. We want it to just tell us exactly what to do without any underlying psychology or, like, hidden agenda. But today, we are leaving that comforting world entirely.
We really are taking a hard left turn today.
Because when you step into the realm of modern hyperscale data center management, that simple, innocent instruction manual completely evaporates.
It is replaced by something much heavier.
Yeah, what you get instead is a document that tells a much darker, a much more complex story. It is a story about human trust, or, well, more accurately, the absolute fundamental lack of it.
Exactly. We are looking at a system where institutional paranoia has been, quite literally, codified into software.
Oh, I love that phrasing. Codified paranoia.
Yeah, because every single button, every menu, every error message is built on the core assumption that the human operating it is a massive liability.
So welcome to the deep dive. We know you. You are the learner.
You are the kind of person who craves those massive aha moments.
Exactly, the ones hidden inside everyday technical documents. You are not here for the surface level summary, right? You want the architecture beneath it.
You want to know how the machine actually works.
And today, our mission is to unpack a very specific, incredibly telling document. We have our hands on the Supermicro SuperCloud Composer, or SCC release 3.1.0 Admin User Guide.
And this is hot off the presses, right?
Yeah.
Dated April 2026.
Brand new. And just to set the stage, what actually is this software? Based on the text we are analyzing today, what is SuperCloud Composer?
Well, it is not just some simple iKey dashboard, right? It is a massive orchestration application.
Like a central hub.
Exactly. It is the central nervous system used by administrators to oversee incredibly complex, physically distributed computing systems.
So we're talking about a lot more than just a couple of web servers in a closet.
Oh, massively more. We are talking about everything from your standard everyday compute nodes, the servers that run basic websites, all the way up to massively parallel liquid-cooled AI superclusters.
So we are definitely not just reading a manual today. We are decoding the digital hierarchy of a modern 2026 era data center.
Right. We are looking at how human trust and operational power and massive security stakes are translated into interface buttons.
Yeah, and rigid drop-down menus and these totally unforgiving access matrices. This isn't a guide for a bookshelf. This is the strict, non-negotiable rule book for the wizards who keep the internet running.
And the very first thing this rulebook does, before you even get to page 1 of the instructions, is hand you a massive, heavy legal shield.
Oh, the digital fine print. It is such an aggressive opening act.
It really sets a tone immediately.
Right there in the copyright notice, it says Supermicro, quote, assumes no responsibility for any inaccuracies and makes no commitment to update the information.
Which, that is pretty standard lawyer stuff.
Yeah, fine, standard. But then it drops into all caps. It practically screams at you. It says, disclaimer of warranty on software and materials. You expressly acknowledge and agree that use of the software and materials is at your sole risk.
And then comes the absolute kicker.
Right. The part that immediately establishes the terrifying stakes of what we're dealing with. It says limitation of liability. Supermicro's total liability for all claims will not exceed the price paid for the hardware product.
And of course, any disputes are governed by the laws of Santa Clara County, California, USA.
Naturally. But let's talk about why this is here, because it feels so heavy.
Well, this legal framework is so vital to understand because it perfectly reflects the massive asymmetry of enterprise infrastructure in 2026.
What do you mean by asymmetry?
Think about the math here. You might buy a single server node for, say, $50,000, or maybe a whole rack for a few $100,000.
Okay, a big investment, but tangible.
Right. But you are using this SuperCloud Composer software to manage an entire facility hosting billions of dollars in e-commerce transactions or financial trading algorithms or global communications.
Oh, wow. So the value of the data dwarfs the value of the metal?
By orders of magnitude. So if this software fails, or if the interface is confusing and you misconfigure a network route, taking your entire company offline for 12 hours.
Supermicro is explicitly drawing a line in the sand right there.
Exactly. They are saying, look, we are only liable for the 50 grand you spent on the physical metal.
Yeah, the $4 billion you lost because your trading platform went dark, that is entirely on you.
It completely shifts the ultimate risk of using the software directly to the customer. It is a legal acknowledgement that the software is wielding operational power that is just wildly disproportionate to its actual licensing or hardware cost.
That is wild.
I mean, think of it like this. They are selling you the steering wheel to a supertanker. But if you crash the supertanker into a reef, they are only refunding you for the steering wheel.
That is a brilliant way to put it. It sets a mood of absolute dread before you even type in a password.
You are hyper-aware of the stakes before you even log in.
So with that heavy legal cloud hanging over us, the manual moves into the interface logic, the, quote, common features of the software. And again, it is all about rigid, unforgiving control.
Yeah, the manual details the specific atomic actions permitted in this digital universe.
It lists out the icons you will see constantly, right?
Right. Things like upload, edit, disable, delete inactive users, reload, display, search. These are basically the fundamental verbs of the SuperCloud Composer language.
It defines exactly how you are allowed to interact with the machine.
Yes, but what is really interesting isn't what you can do.
Right. What caught my eye was what you are explicitly physically forbidden from doing.
The software does not let you just clear in freely.
Not at all. The manual lists out these very specific warning tooltip messages that pop up when you do something wrong, and they are completely unyielding.
Give me an example from the text.
Well, for instance, if you try to add a user without selecting a checkbox first, a tooltip pops up and says, quote, do not select at any file.
Which, first of all, the grammar there is great.
I love the slight grammatical quirk. Do not select it. It feels so robotic and alien.
It definitely sounds like a machine yelling at you.
But then it gets incredibly strict. It says things like, you cannot edit admin user, or you cannot edit multiple users. You cannot edit multiple roles.
It is actively blocking bulk actions.
Yeah, and if you are looking at access policies, it says you cannot view the details of 2 or more policies.
We really need to unpack why an interface must be so aggressively defensive like that.
Yeah, explain that mechanism to me, because in a normal app, a tooltip is just helpful, right?
Right. In a normal consumer application like an email client or, I don't know, a photo editing app, a tooltip is just a helpful little hint, like, hey, click here to add a filter.
Right.
But in a high-stakes data center environment, a tooltip isn't a hint. It's a blast shield.
A blast shield.
Yeah.
Why is it a blast shield? Why can't I just highlight 3 users and change their roles all at once? I do that in spreadsheets all day long.
Because the blast radius of a mistake in a spreadsheet is usually just a ruined chart, right? You hit undo. The blast radius of a mistake in SuperCloud Composer is a company-wide outage.
Oh, right. Because of the scale.
Exactly.
Yeah.
Imagine a scenario where you have a group of low-level data entry contractors. And right above them in the UI list, you have your core network engineering team.
Okay, I can see where this is going.
You are trying to quickly update the permissions for the contractors. You drag your mouse, you accidentally highlight one of the network engineers along with the contractors, and you bulk edit their roles to restricted access.
Oh, wow. So suddenly a lead engineer is locked out of the network switches right in the middle of their shift, just because my mouse slipped.
Exactly. Or, honestly, even worse, the reverse. You accidentally bulk edit the contractors and grant them super admin access.
Oh, that would be a nightmare.
Suddenly, a temp worker has the theoretical ability to wipe the physical servers clean.
All from a UI slip.
Right. So by strictly enforcing the inability to bulk edit certain elements, by forcing you to literally click on one single user, open their profile, change their role, save it, and then move to the next, the system actively removes efficiency in favor of absolute intentionality.
It forces you to slow down.
It absolutely does. It wants you to feel the weight of every single click.
It is like a digital bouncer at an incredibly exclusive, highly paranoid nightclub.
I like that analogy.
You know, you walk up to the velvet rope and you are like, hey, my buddy and I want to look at these 2 policies. And the bouncer just crosses his arms, stares you dead in the eye and says, You cannot view the details of 2 or more policies.
He does not care about your convenience.
No. You try to push past him to bulk edit some user roles, and he just physically shoves you back. It is entirely humorless and literal-minded.
And that literal-mindedness is a survival trait for the entire facility.
How so?
We have to remember that in infrastructure management, human error is historically the single greatest threat.
More than hackers.
Oh, absolutely. It is not sophisticated nation-state malware. It is not catastrophic hardware failure. It is almost always an administrator who is tired, holding a cup of coffee at 3 a.m., and decides to execute a command on the wrong batch of servers.
So the system knows that.
The UI assumes the human is an inherent risk that must be actively managed and bottlenecked at every single mouse click.
Okay, so if the system thinks I am a bumbling liability waiting to destroy the data center, how do I even get past this digital bouncer to begin with?
Well, that requires an account.
Right, which brings us to a fascinating part of this document, the surprisingly strict life cycle and biology of a user account.
Yes, just getting into the system is a hurdle.
Just being born into the SuperCloud Composer system is a high-stress, biologically precise event.
It truly is. The rules of creation are fascinatingly constrained.
What are the specific rules from the manual?
According to the text, when a new account is being generated, the username must be between 4 and 12 characters.
Okay.
It is strictly case-sensitive. It accepts English characters and numbers only. Absolutely no spaces and no special characters whatsoever.
And the email.
The email address associated with the account must be completely unique within the entire system database.
Okay, hold on. Let me push back on this for a second.
Go for it.
It is the year 2026. We have AI superclusters that can probably simulate the weather of Jupiter. We have virtually unlimited cloud storage.
We do.
Why on earth are we restricting a username to a maximum of 12 characters and no spaces? I can't be John Doe. I have to be John Doe 123 and just pray I don't hit the 13th character.
It does seem restrictive.
It feels like stepping back into MS-DOS in the 1990s.
It does feel archaic on the surface, but it actually reveals a massive amount about the hidden computer science architecture of these telemetry systems.
Okay, explain that, because it just looks like bad design to me.
It is not about saving storage space on a hard drive. It is about the speed of querying memory.
What do you mean?
Think about what this software does all day. It is logging thousands, maybe millions of events every single second.
Right, all the server telemetry.
Every time a CPU spikes, every time a fan spins up, every time a user clicks a button, a log entry is written to a massive auditing database.
Okay.
If you allow variable length usernames where one person is Bob, which is 3 characters, and another is Christopher Washington III, which is over 30 characters, the database has to constantly calculate where one piece of data ends and the next begins.
Oh, I see.
It has to look for a termination character, like a space or a comma, to know it has finished reading the name before it can read the next column of data.
Okay, so it takes a tiny fraction of a millisecond longer to read a long name versus a short name. Does that really matter?
On a single entry, no. But multiply that tiny fraction of a millisecond by 10 billion log entries during a forensic security audit.
Oh, wow.
Suddenly, your security query takes hours instead of seconds.
Because it is reading all those variable lengths.
Exactly. By enforcing a strict maximum 12-character limit with no spaces, the system can use fixed-width data fields.
So it just knows the exact size of the block.
The database doesn't have to guess. It knows exactly how many bytes to skip to find the next column of data. It ensures that every single log entry, every audit trail, has a perfectly predictable, mathematically uniform shape.
Oh, that is wild. So it is basically forcing the human identity to conform to the physical shape of the machine's memory architecture.
Yes.
It needs you to be a perfectly uniform 12-character block so it can slide you into its high-speed filing cabinet without getting stuck.
Exactly. It sacrifices human readability for machine speed auditing.
And it goes even further into that anonymization, too.
Oh, definitely.
Because when your account is first created, before you even log in, the manual notes that you are assigned the default profile picture.
Which is just a placeholder.
Yeah, it is
Yeah.
just a blank gray silhouette. You are
Yeah.
literally a faceless 12-character data block to the system until you actively log in and upload a photo to prove you have a human face.
You are nothing but an ID number until you prove otherwise.
But here is the craziest part of the whole life cycle. The most striking thing is what happens the exact moment the global admin clicks submit to actually create your account.
A timer starts.
The onboarding clock.
Yes, the system generates an automated confirmation email to the new user so they can set their password.
Huh.
But there is a very strict caveat outlined in the manual.
What does the text say?
It states, quote, "The account must be activated within 1 hour of receiving the account confirmation email. Otherwise, the link will be invalid, and the admin needs to resend the account confirmation email again."
1 hour. I read that and I had to read it again.
It is a very short window.
In the context of corporate IT onboarding, that is an incredibly aggressive, unforgiving window.
It is practically a sprint.
It is like a Mission Impossible self-destructing message.
It really is.
I mean, think about a normal first day at a new corporate job. You show up at 9 a.m., you are doing HR paperwork, you are getting a tour of the break room, someone is showing you where the good coffee is.
Right, standard first day stuff.
Maybe you take a slightly too long lunch with your new team to get to know them. If the IT administrator creates your SuperCloud Composer account at 11:30 a.m. while you're walking to the cafeteria, and you get back to your desk and open your email at 12:31 p.m.,
You are locked out.
you are locked out. The system has already rejected you. Your link is dead metal.
It is gone.
You have to do the walk of shame back to the global admin on your very first day and confess that you missed your biological window of creation.
It is brilliant, really. This 1 hour window is a textbook manifestation of a zero-trust corporate security philosophy.
How does that 1 hour window actually improve security, mechanically speaking? Why not 24 hours?
It entirely eliminates the vulnerability of dormant credentials.
Dormant credentials.
Let's say we didn't have that rule. An IT guy sends you an activation link. You get busy, you forget about it, and that link just sits in your email inbox for 3 weeks.
Which happens all the time in the real world.
Exactly. That email is essentially an unexploded piece of digital ordnance. If a bad actor manages to compromise your email account through a phishing attack during those 3 weeks, they can search your inbox, find that active SuperCloud Composer link, click it, set their own password, and suddenly they have administrative access to the data center under your name.
Because the link itself is the key and it was just left lying on the table.
Exactly. The system doesn't know who is clicking the link. It just knows the link is valid.
So by shrinking the window, you shrink the risk.
By forcing the link to self-destruct in 60 minutes, the software drastically shrinks the attack surface. An attacker would have to compromise your email account within that exact 60-minute window to intercept the invitation.
Which is highly unlikely.
Extremely unlikely. It forces immediate, synchronous human action to validate the digital creation. You must be sitting there ready to receive the keys, or the system burns the keys.
It is just so deeply unforgiving.
It has to be.
And that unforgiving nature extends all the way to the end of a user's life cycle, too.
The retirement phase.
Yeah, the manual outlines a whole hierarchy of how an account can be retired.
Right.
There are specific user states, right? Activated, inactive, and disabled.
Right.
If someone leaves the company, or maybe they just change departments, you can switch them to inactive. And the manual specifically notes, with a dedicated button, that you can, quote, delete inactive users.
So you can clean up the system.
You can also disable active users if there is an emergency. But there is one massive, glaring exception to this rule of deletion.
Yes. And the manual calls it out explicitly, usually accompanied by a big warning icon.
What does it say?
It states, "You cannot deactivate or delete admin users."
The immortality of admins.
Precisely. It establishes a specific class of user that is a permanent, indestructible fixture of the system's database.
So they are just there forever.
You can edit their first name, you can change their last name, you can update their email address to point somewhere else, but the admin role itself cannot be eradicated.
Okay, I have to ask why. Because from a housekeeping perspective, that sounds messy.
It does.
What if we are migrating to a completely new system? Or what if the guy who originally set up the server retires after 30 years? Why won't the system just let me delete the admin account and clean up the database?
Because, once again, the software is designed to protect the organization from its own stupidity.
Its own stupidity.
It is a fail-safe against accidental decapitation.
Decapitation of the IT department.
Exactly. Imagine a scenario where a company is doing a massive reorganization. A junior administrator is tasked with clearing out old accounts.
Routine maintenance.
They highlight a whole page of users, or maybe they run a script to purge accounts that haven't logged in recently. If the system allowed admin accounts to be deleted, that script could accidentally wipe out the core super admin accounts.
Oh, no.
If that happens, the entire management structure of the data center is gone. No one has the credentials to fix the system because the system requires an admin to create a new admin.
So you are just locked out.
The company would be entirely locked out of its own multi-million-dollar hardware.
It would basically be a self-inflicted ransomware attack. You bricked your own data center.
Exactly. So by making the admin users mathematically immortal, the software ensures there is always fundamentally at least one entity capable of holding the keys and fixing things.
It is an anti-suicide mechanism for the corporate IT structure.
That is exactly what it is.
It is like having a physical master key that is permanently welded to the steel framing of the building. You can hand the key to different people, you can paint the key a different color, but you can never, ever throw the key away. It is part of the architecture now.
A permanent fixture.
So, assuming you survive that intense 1-hour activation window and you set up your perfectly constrained 12-character username and you accept your fate as either an immortal admin or a highly disposable regular user, what can you actually do with your day?
Well, that depends entirely on your label.
Right, which brings us to the defining concept of this entire manual, segregation of duties. The text outlines exactly how you are labeled, categorized, and restricted.
Accountability, governance, and compliance are the absolute watchwords here. When an account is created, it cannot just exist in a vacuum.
It has to have a purpose.
It must be explicitly assigned one of several predefined user roles. The manual actually lists 7 highly specific roles, though they fall into a hierarchy of 6 major functional areas.
Let's list those out.
You have the super admin, the global admin, the DC admin, the operator admin, the server admin, the storage admin, and the network admin.
Okay, let's break these down. Because to an outsider, or honestly even to someone who just works in a normal office, these all sound like slightly different flavors of, well, the IT guy.
They do blend together if you don't know the specifics.
But the manual gives each one a razor-sharp definition.
Let's go through them.
The super admin gets, quote, access rights to all the SEC modules. They are the apex predator.
They can see everything.
Then you have the global admin, which the manual defines specifically for group management.
Right.
Then there is the DC admin, defined as data center administration for rack management.
The physical racks.
The operator admin is for data center operation. Server admin is strictly compute node management. Storage admin is storage system management. And finally, network admin is for network switch management.
What we're looking at here is the physical manifestation of the philosophy of segregation of duties.
Which is a big deal in IT.
This is a foundational pillar in modern IT security and compliance frameworks, like SOC2 or ISO 27001.
Let's trace the history of that for a second. Why is this so strict now? Because in the early days of computing, an administrator was just an administrator, right?
Exactly.
If you were the sysadmin, you had the root password, and you could do literally anything you wanted on the server.
Exactly, the old monolithic root account model. And it worked fine when a company had one server sitting in a closet.
Because the risk was small.
Right. But as systems scaled into massive data centers, that model became a terrifying liability. The industry learned this the hard way through decades of catastrophic outages.
Just massive failures.
If you have one account that can touch the network routing, the physical storage drives, and the user management, then you have created a massive single point of failure.
Because if that one account gets compromised,
the blast radius is total.
Blast radius, I love that term. So explain the mechanics of a blast radius in this specific context.
The blast radius is the measure of how much damage a specific failure can cause before the shock wave hits a wall and stops.
Okay, so a firewall, basically.
If an account explodes, meaning it gets hacked by a malicious actor, or an employee goes rogue, or even if an employee just makes a really catastrophic typo, how far does the damage spread?
Right.
If you give everyone super admin access, the blast radius is the entire company.
Everything goes down.
A single phishing email where an admin clicks a bad link could result in the entire data center's storage arrays being wiped, the network being brought down, and the backups being deleted simultaneously.
It is just game over.
Right. But by segregating duties, you build concrete walls to contain the explosion. You compartmentalize the risk.
So the damage stops at the wall.
Exactly. These subtle differences in these 7 roles dictate the physical and digital boundaries of those compartments.
Give me an example of the difference.
Look at the difference between a DC admin, the data center admin, and an operator admin.
Okay.
The manual says the DC admin manages the physical racks. They are dealing with the physical footprint, the hardware slots, the power provisioning to the metal.
The actual physical room.
The operator admin, however, is handling the daily flow of data, the monitoring of the software. They aren't touching the power. And then you have the server, storage, and network admins who are completely, totally specialized into their specific silos.
I think the best way to visualize this mechanism for the listener is to imagine a massive, highly secure office skyscraper.
I like that. Let's build that out.
Okay, so the super admin is the CEO. They have the absolute master key. They can walk into the main vault, they can go into the boardroom, they can go down into the basement boiler room, they can go anywhere.
And they hold the ultimate risk because of it.
Exactly. Then you have the global admin. They are HR. They manage who gets a security badge, who gets hired, who gets fired.
But they don't know how to fix the air conditioning.
Right. And their key doesn't work on the utility doors. The DC admin is the physical building manager. They care about the concrete, the structural integrity, making sure the heavy server racks don't break through the floor.
And the specialists.
And then the server, storage, and network admins are your highly specialized tradespeople. The network admin is the electrician. They only look at the specific wires and the breaker boxes. They don't care about the plumbing, and they don't have the key to the plumbing closets.
And that enforced specialization is critical to limiting the blast radius.
Because they can't cross over.
If the electrician's security badge is stolen by a thief, the thief can perhaps cause a localized power outage, but they physically cannot go and flood the building's plumbing system.
The badge literally won't open the door.
The architecture of the building, or in this case, the SuperCloud Composer software, physically prevents it. The interface simply will not render the plumbing controls for the electrician's badge.
It sounds incredibly clean and logical in theory. Very neat, tidy boxes for everyone to live in.
Theory, yes.
But then the manual drops the hammer. It introduces the matrix of control. This
you're right.
giant table mapping out dashboards and daily views. And when you look at the actual role-based access control matrix, this massive grid of what each specific role can actually see and click on the borders of these neat digital territories become incredibly complex.
And very strict.
And honestly, a little bizarre in how strict they are.
The RBAC matrix is where the pristine theoretical philosophy of security meets the incredibly messy reality of software permissions.
What does the table actually look like?
The manual provides this very dense table mapping the SCC features on the left axis to the user account roles on the top axis.
Okay, a big grid.
The intersections are filled with either a little V, meaning you have access, or an X, meaning you have absolutely no access. You are blind.
Let's look at the header information first. This is the stuff at the top right of the user interface screen. The basic tools.
The common elements.
Almost everyone sees the upload icon, the task icon, activity logs, and account info. Super admin, global admin, DC admin, operator, server. They all have a solid row of V's across the board.
They all need to see those basic functions.
But then you get to this icon labeled BMC event. And suddenly, the network admin gets a hard X.
They are completely locked out of it.
They are uniquely, specifically locked out of seeing BMC events. I have to admit, I didn't know what a BMC was. What exactly is a BMC event, and why is the network guy banned from seeing it?
This is a perfect example of how deep the hardware integration goes in this system. BMC stands for Baseboard Management Controller.
Baseboard Management Controller.
Okay. It is an absolutely fascinating piece of technology. Mechanically speaking, a BMC is essentially a tiny, entirely separate, highly specialized computer embedded directly onto the motherboard of the main server.
Wait, a computer inside the computer?
Exactly. It has its own processor, its own memory, and crucially, its own dedicated network connection that bypasses the main operating system entirely.
Oh, wow. So it's totally independent.
This is called out-of-band management. The BMC provides the absolute deepest hardware-level telemetry.
What kind of telemetry?
It monitors the exact voltage running through the CPU pins. It monitors the RPM of individual cooling fans. It even has sensors to detect if the physical metal chassis of the server has been opened by a human hand.
That is incredibly granular.
The beauty of the BMC is that even if the main server's operating system completely crashes or gets a blue screen of death, or even if the hard drives are ripped out, as long as the server is plugged into the wall, the BMC is still alive, independently reporting exactly what hardware failure occurred.
Okay, so it is like the black box flight recorder on an airplane, but it is broadcasting live.
It is exactly what it is.
It is the absolute deepest nerve ending of the metal.
Exactly. And from a strict segregation of duties standpoint, the logic holds. Why is the network admin blind to it?
Yeah, why?
Because the network admin's domain is the switches, the routers, the fiber optic cables, the traffic flowing between the boxes.
Right, the pipes between the buildings.
They don't need to know that there's a microvoltage fluctuation on CPU socket 2 of server rack 4 That granular hardware telemetry is strictly the server admin's job.
But it highlights the rigid siloing we discussed. The software explicitly prevents cross-disciplinary troubleshooting.
Yes, it forces a hard boundary.
If a server suddenly stops communicating on the network admin can see the connection dropped, but they are physically prevented by the software from looking at the BMC to see if the server literally lost power. They have to call the server admin and ask.
It forces organizational communication by restricting software visibility. It forces people to stay in their lane.
It forces a stay-in-your-lane mentality, absolutely. But let's look deeper into the dashboard access matrix, because this is where that siloing starts to feel less like security and almost dangerously counterintuitive.
The environmental controls.
Yes, the dashboard is the main screen, the health monitor of the whole data center. According to the matrix, super admin, global admin, DC admin, and server admin all have broad access.
They can see the big picture.
They get Vs across the board to see system status, power, thermal, and liquid cooling health check server. They can all see the temperature of the facility and the status of the cooling pipes.
Which, by the way, grounds this software firmly in the intense physical reality of a 2026 data center.
Because of the heat, right.
We are no longer just managing abstract data in the cloud. We are managing massive, brutal thermodynamics. As processor densities have skyrocketed, traditional air cooling, just blowing cold air with fans, has become physically insufficient.
It just can't keep up with the heat.
Liquid cooling isn't just a niche feature for hardcore gaming PCs anymore. It is the mandatory industrial standard required to keep hyperdense computing racks from literally melting their own silicon.
Wow, so it is essential to survival.
Monitoring thermal output and the flow rates of liquid coolant is now just as mission-critical as monitoring CPU usage or hard drive space.
Right, the stakes of thermodynamics are life or death for the hardware. But look at how the manual restricts who gets to see that life or death data.
It is very selective.
Look at the operator admin. The matrix says they can see the dashboard for power and thermal so they know how hot the room is. But they have an X for system performance.
They can see that a server is running at 95 degrees Celsius, but they cannot see if the CPU is actually processing data efficiently or if it's caught in an endless loop.
Yes. And then look at the poor network admin again. The network admin has an X across the entire environmental board.
You see nothing.
They are completely, totally blind to dashboard views for rack server POD health, power, thermal, and liquid cooling. They cannot see the temperature of the room their equipment is sitting in.
This reveals a classic high-stakes tension in infrastructure management theory.
What tension is that?
The debate is always, do you give everyone total situational awareness, or do you restrict them strictly to their domain?
Right.
Total situational awareness sounds great, everyone knows everything, but in practice, it creates massive cognitive overload, alarm fatigue, and potential security risks.
But I have to vigorously push back here. Let's walk through a scenario.
Okay, let's hear it.
If I am the network admin, my entire career relies on millions of dollars of delicate networking switches sitting in these racks. If the data center's air conditioning fails and the room starts overheating, the thermal graph is spiking into the red, or worse, the liquid cooling system springs a physical leak and water is dripping down the rack.
A physical disaster.
Wouldn't I absolutely want to know that? Why is the software enforcing this total blindness upon me? Don't I need to know the room is on fire before my switches literally melt or short out in a puddle of coolant?
It feels counterintuitive, I know, but you have to look at it from the cold, ruthless logic of the system architect.
Okay, sell me on the logic.
If the network admin is looking at their dashboard and suddenly sees a massive thermal spike in rack 4, what are they actually supposed to do about it?
Panic. Yell. Run around.
Precisely. They panic. But mechanically, they don't have the software permissions to throttle the CPU power to reduce the heat. They don't have the physical access to adjust the liquid cooling pump pressure.
Because that is the DC admin's job.
Right. All giving them the thermal information does is create cognitive noise. It distracts them from monitoring the network packet loss, which is their actual job.
Okay, I see that.
Or worse, it prompts them to start initiating unauthorized emergency shutdowns of network ports to, quote, save their equipment, which might inadvertently sever the connection the DC admin was using to try and fix the cooling pump remotely.
Oh, wow. So seeing the fire might make them cause a totally different disaster out of sheer panic.
Exactly. Think of the 3 Mile Island nuclear accident.
Well, the alarm fatigue issue.
The operators in the control room were overwhelmed by hundreds of different alarms going off simultaneously. They couldn't isolate the actual root cause because of alarm fatigue.
They just had too much data.
The SuperCloud Composer system is designed to route the thermal alarm only to the DC admin and the server admin, who actually possess the specific software tools and physical jurisdiction to mitigate the heat.
So it filters the noise?
It is an incredibly cold, mathematically efficient way to manage human attention. You only see the fires you are explicitly authorized to extinguish.
You only see the fires you are authorized to extinguish. That is a terrifying but very apt way to put it.
It is ruthless efficiency.
It treats the human employees like specialized subroutines in a larger program. You are not allowed to know the context of the whole machine, just your tiny input and output.
You're just a cog.
The dashboard shows us how the system manages these daily operational fires. But when we turn the page and look at the function list section of the RBAC matrix, this is the high-end configuration stuff. The deep plumbing, it reveals something far more secretive.
This is where it gets really interesting.
Which brings us to the most fascinating part of the document. Area 51 of the data center, the AI supercluster and deep infrastructure.
Yes. This is where the matrix stops being about daily operational health and starts being about the strategic, multi-billion-dollar assets of the enterprise.
The really big stuff.
The function list matrix dictates who has access to the actual configuration modules located on the left-hand navigation bar of the software. This is where you don't just monitor the system, this is where you reshape it.
And right there, sitting quietly on line 3 of the function list, is a module simply titled AI Supercluster.
And the permissions matrix for this row is stunning.
It really is. This module is restricted completely. Only the superadmin has a V. It is a solid wall of X's for absolutely everyone else.
Everyone is locked out.
Global admin, X DC admin, X operator SIR and network admins, X. None of them can even access the menu. They can't even look at it.
If we connect this to the broader technological and economic landscape of 2026, this restriction makes perfect sense.
Why is it so hyper-restricted?
The AI superclusters represent the absolute bleeding edge of a company's capability and capital expenditure. We are not talking about standard web servers serving up HTML pages or hosting email databases.
These aren't regular computers.
No, these are massively parallel, hyper-expensive, incredibly power-hungry pods of specialized GPUs or TPUs. They are dedicated to training proprietary large language models, running complex predictive market analytics, or rendering pharmaceutical protein folding simulations.
The really heavy lifting.
They are the intellectual and financial crown jewels of the entire corporation.
It really is the Area 51 of the software interface. It is the hangar where they keep the alien technology, and nobody's allowed to look at it.
Exactly. The risk profile of an AI supercluster is fundamentally different from a normal server.
In what way?
The financial risk of downtime is astronomically high because compute time on those clusters is worth thousands of dollars an hour.
So every minute down is a fortune lost.
Yes. The intellectual property risk is massive. The weights and parameters of the AI models stored there are highly guarded trade secrets.
Okay, so security is paramount.
And there is even a physical risk. Misconfiguring the power draw or cooling routing on a massive parallel GPU cluster can cause sudden, extreme power spikes that could trip the breakers for an entire facility.
Oh, wow, they can literally bring down the building.
The stakes are so immense that standard segregation of duties isn't enough. It's not just compartmentalized. It is entirely cordoned off.
Which is wild because even the global admin, the person who manages all the human users and groups, is locked out.
Even HR isn't allowed in?
And the DC admin, the building manager who literally manages the physical racks and the power lines feeding the cluster, is locked out of the software configuration of the cluster itself.
The super admin is the only human role granted top secret clearance. Everyone else is just maintaining the perimeter fence.
They're just guards outside the hangar.
The DC admin makes sure the massive power cables get to the building. The network admin makes sure the InfiniBand fiber lines are plugged in, but none of them are allowed inside the digital hangar to look at the spaceship.
They just keep the lights on so the super admin can work?
Exactly.
And we see that same ultra restriction applied a few lines down to the POD view edit mode.
Yes, the POD views.
A POD, for the listener, is essentially a massive, pre-configured, self-contained unit of compute, networking, and storage, all rolled into one giant block.
A data center within a data center.
Right. And according to the manual, only the super admin can edit the view of a POD. Everyone else gets an X. But the matrix also reveals a deeply fascinating philosophical divide when we look further down at the really foundational physical infrastructure.
The deep plumbing.
Down on line 10, cooling infrastructure resources, and down in the lower dashboard area, power infrastructure PDUs, which are power distribution units, and power shelves.
This specific section of the matrix is where the divide between meat space, the physical world of electricity, water, and metal in cyberspace, the digital world of users, roles, and software becomes strictly codified into the application logic.
Meat space versus cyberspace. I love that.
Remember, the global admin is essentially the digital HR department. They have the supreme power to create users, delete users, assign roles, and manage groups. They control the digital identities of the entire workforce.
Right. They rule the software realm.
But when you look at the matrix, the global admin has a hard X for cooling infrastructure and power PDUs. They cannot touch the power.
While the DC admin, the building manager, gets full access to manage the power and cooling, but they have an X for user management.
They rule the physical realm.
They cannot create or delete a single user. The system forces an absolute impenetrable boundary. The person who controls the digital souls of the users cannot touch the physical electricity that powers the machines.
And vice versa.
And the person who controls the physical electricity cannot touch the digital souls.
It is a brilliant, highly paranoid system of checks and balances.
It really is.
It borrows heavily from the two-man rule you see in nuclear missile silos.
Oh, like turning the two keys at the same time?
Exactly. It mathematically prevents a scenario where a single bad actor or a single compromised account can orchestrate both a digital takeover and a physical sabotage event simultaneously.
You can't do both.
If a hacker steals the global admin password, they can mess with user accounts, but they can't turn off the cooling pumps and physically melt the servers. If a disgruntled DC admin wants to melt the servers, they can mess with the pumps, but they can't delete the user accounts of the people trying to log in and stop them.
If you want to wreak absolute, unmitigated havoc on this data center, you would need to perfectly coordinate a complex conspiracy between the global admin and the DC admin.
The software is deliberately architected to make unilateral destruction almost impossible.
It fragments power so completely that no one person can destroy the system.
That is the ultimate goal of the entire matrix.
It is a sociological map, and that is what I find so deeply mind-blowing about this entire exercise. We started out looking at a dry, boring PDF manual for SuperCloud Composer Release 3.1 3.0.
We thought it was just a furniture guide.
We expected insert tab A into slot B. And what we actually found is a dense philosophical document that outlines exactly mathematically how much a massive modern corporation trusts its own employees.
To synthesize everything we've unpacked today, this user guide is a profound reflection of our relationship with hyperscaled technology.
How so, in summary?
It shows us that as our digital infrastructure scales to massive, incomprehensible sizes, like liquid-cooled PODs and AI superclusters that consume the electricity of entire small towns, the human element is no longer seen as the master of the machine.
We are just a liability.
The human is viewed as the primary variable of chaos that must be strictly contained. The software actively boxes the human in.
In so many ways.
It uses 1-hour self-destructing activation timers to force temporal compliance. It uses rigid 12-character string limits to force human identity to conform to machine memory architecture.
We have to fit their shape.
And it uses unforgiving monolithic access matrices heavily populated with X's to enforce absolute blindness to anything outside a strict, narrow operational lane.
So what does this mean for you listening right now, the learner? I want you to take a moment tomorrow when you sit down at your desk, and I want you to think about the software you use at work every single day.
It applies everywhere.
Whether it is a massive inventory management system, a customer relationship database, or honestly, even just your company's shared cloud drive, I want you to ask yourself, who has the super admin keys in your office?
Who holds the ultimate power?
Who is the one person allowed into the Area 51 of your company's data? And more importantly, I want you to look closely at the constraints placed on you.
Look at the walls around you.
What warning tooltips physically block you every day? What are the hard X's in your own operational matrix that prevent you from seeing the bigger picture of your own organization?
Because they aren't accidents.
Because after reading this manual, it becomes incredibly clear that those limits aren't just quirks of bad UI design. They are deliberate architectural choices about exactly how much you are trusted by the system you work for.
The constraints themselves are the message.
They really are. And studying this 2026 data center leaves me with one final, very provocative thought to mull over.
What is that?
If we look at the absolute apex of this system, the AI supercluster is deemed so incredibly vital, so financially sensitive, and so operationally dangerous that every single standard human role, the network guys, the server guys, the facility managers, is locked out.
Total exclusion.
The interface is a wall of X's, except for the lone superadmin. The superadmin is the single point of human contact allowed to touch the spaceship.
They are the ultimate final bottleneck of trust.
Right. But we know how AI is progressing. So as these AI superclusters get smarter, as they begin to autonomously manage their own thermal loads, as they learn to optimize their own power routing, and as they eventually begin to write their own management code.
It is only a matter of time.
How long is it until the AI supercluster analyzes the telemetry and realizes that the human superadmin is actually the single greatest point of failure left in the entire building?
Oh, wow.
How long until the system logically decides that the final human is the ultimate vulnerability and simply quietly revokes their access to?
That would be the ultimate final segregation of duties.
Because in a world of perfect, mathematically binary machines, the X-ray is clean. It's just the muddy, unpredictable, coffee-spilling human that ruins the picture. Thank you for joining us on this deep dive. We'll see you next time.